There is a class of materials that use these sugars, and I had been for a different project looking into them, and I realized that I could use these sugars to make better materials for carbon dioxide capture. So that's really how I started to look into these materials, and then from there, I just kept trying to optimize them and find better ways to make these materials.
Mary Zick is currently pursuing her Ph.D. in chemistry at Cornell University. She recently created a carbon dioxide filter that might be a solution to climate change in the future.
Our lab is pretty focused on trying to find solutions to problems that folks in industry will actually use someday. With carbon capture, there's a lot of research and a lot of people trying to find new solutions to these problems. So there's a lot of expertise out there, which is good.
Dr. Phillip Milner is the assistant professor of chemical and chemical biology in the College of Arts and Sciences at Cornell University. He collaborated with Mary on this filter, which is made up of sponge-like materials made from sugar and low-cost alkali metal salts that can capture CO2.
I'd say the thing that sinks most materials is cost. If we try to do carbon dioxide capture on massive scale in the US or across the world, whatever material we use for it is going to have to be one of the most widely produced materials on Earth, just by the sheer volume of the emissions that we have. But the nice thing is, Mary's materials that she's been making are made out of sugar and these metal salts. I always say it's like sugar and baking soda essentially mixed together. So we very easily could buy everything we would need and make 10 or 100 grams or more of these materials. So I think that's kind of the stage we're at now.
Zick experimented with sugars in a previous project and realized she could use them to make better materials for carbon capture. She created a powder-like material called crystalline powder that can be used as a filter to capture CO2 containing gas. Now she's trying to optimize them to make them hold even more weight. In recent years, no one has done something quite like what Mary has created. However, Cornell students have always been trying to develop new approaches to creating materials.
She came up with a much better way to make these than how they were made previously. So we can now rapidly make large amounts of these as opposed to small volumes with sort of a limited, range of materials, which is what was previously in the literature. So that gives us some hope that we could make, 100 grams or a kilogram, and then that's enough where you could go to an industrial partner and say, we have this jar of stuff right now. It's something that you could actually look at. So I think that's our hope. So we'll see how it goes.
Dr. Milner's hope is that they will meet the industrial demand for these materials in order to implement them.
I'm most excited about to try to optimize this material even further to make it even better, because it's already good, but we can make it great.
Both Zick and Dr. Milner are hoping to make that happen and test the filter on Cornell's power plant on campus. They're hoping they can turn it into a testing station for future ideas. For FingerLakes1.com, I'm Megan Hatch.